Hi everyone. So this is my second video. My last video was based on um, types of data. Now, another major issue we run into is we get given data, lots of data, but we don't quite know how to analyze it or what types of graphs to draw in order to analyze the data. Well, the reason we analyze data, by the way, is because we've had a question a problem, a question which we were investigating, and we go through that whole PP deck cycle, the problem, plan, data, analysis, conclusion, of course. So you all know the PP deck cycle. So let's look at an image very quickly. Um, so I think I should have done it. Just stick to this one. So there we go. Problem. What is your question that you're solving? There's usually a rationale behind it why you'd like to solve it, of course. Um, your planning bit, what to measure, etc. So we've got data. Sometimes it's actually quite nice just to start off with data and explore it. If we don't quite know how to navigate, our exploration is useless. So, likewise, if we don't quite know how to or what appropriate graph to draw, to find links, correlation, etc. It's quite futile, the effort. So here we go. I've gone to NZ Grapher, Jake formats, blah, blah, blah. There's built-in data here, and there's something about rugby players. So this one here, you've got about how many? Quite a bit, 134 or 135 rugby players. You've got the position they play, if they're a back or if they're a forward. Their weight, I presume this is in kgs, of course. It must be in kgs, can't be in pounds, of course. If you're 82 pounds and you're back, I don't think this is adults playing rugby. But anyway, moving on. Country, South African players and Kiwi players, of course. We all know who the better team is, of course. Height, yeah, that's all we have. So what I'm going to do, I would like to explore this data and see what it's telling me. So I'm just going to go and draw a graph. Let's go and choose a dot plot, which is also known as box and whisker. Just click on that. Now, ignore the error bit. In order to draw a box and whisker plot, I'm mainly doing it to compare if one data set is larger or smaller than the other. That's the point of box and whisker plot. So here I am, dot plot. I will not, let me make a mistake. If I put weight and height, that's not really the right type of variables to choose to draw a box and whisker plot. I know the computer does do it for you, but actually, in order to draw a box and whisker plot, you need a numerical variable on your x-axis and a categorical. So a numerical variable, remember this, you need a qualitative variable here, preferentially a continuous data here, and you need something which comes in categories, nominal data. It could be, position, for example. So let's go and choose position of a rugby player. And now we're looking at the whites. There we go. You see, this is a better representation. So this is a dot plot. Okay, and the dot plot is very similar to a box and whisker plot, but box and whisker plot is of course much more powerful. So I can decrease the point size here. I can. Yes, I can. I can also click on box and whisker box plots, and I get that. I can also click on summaries. Now, what summaries does, it finds me some very important numbers. In fact, if you remember, a box and whisker plot needs 5 very important numbers in order to be constructed. It's called the 5-number summary. So this one here is the minimum value. So for the rugby players who play in a back position, now, for those of you who don't know rugby, backs are people who play the back, like number 15, your full back, 14, 11 wings, and you've got your 12s and 13s, etc. Forwards are usually numbers 1, 2, 8, 9, I think. They're big, bulky players, they drive back forward, etc. Here's your minimum data value, 77 kgs. your maximum is 105 kgs. So minimum, maximum. Now, a lot of people sometimes randomly just draw a line in the middle and think, okay, median should be here. Not quite. Median is the middlemost value. So our median for Bex is 92 kgs. Then we have something called LQ, lower quartile. Lower quartile is like the median of the lower half. So that's the lower half. And this is the median of the lower half, known as lower quartile. And of course, this is the upper quartile. So this data comes in sections of 25%. Now, why 25%? Because this is 1/4 of the data, 25, second quarter, another 25, 50, third quarter, 75, and the last quarter, 100% of the data. It also gives you something called ST, standard deviation. Don't worry about that. You don't really need it. It's mainly for higher level maths is 12 and 13. The number of rugby players who were backs were 59. Yeah, so that you need 5 numbers to construct this. There's something called IQR, interquartile range. An interquartile range is the difference between the lower quartile and the upper quartile. So 96. Take away 88 is 8 kg. So your interquartile range is 8 kgs. So that means there's a variation of 8 kgs in here. That number to that number is a difference of 8 kgs. So the width of that box is 8 kgs. Here, the width of this box is lower quartile 104.5, 117. So that's what, 12.5 kg. So that's a larger interquartile. So once again, a box and whisker plot is drawn to compare, to find if there's a difference between two numerical variables. And the numerical variables, of course, itself fall off some categories. So it could be forward or backs. It could be the weight of blue cars or the weight of red cars. I don't know why you do that, but let's say someone goes, I wonder, if blue cars weigh more than red cars. Of course, there's a lot more to it, but it's an example. Or I wonder if the weight of snapper caught at Kawakawa Bay is any different than the weight of snapper caught, I don't know, let's say some other beach. Let's go somewhere up north, maybe, I don't know, Cooper's Beach or something. I don't know if you can fish there anyway. But that's box and whisker plot and the purpose of that. I have another window open here, so I'm going to, or tab rather. So I'm going to go to that tab. Once again, I've got the rugby data. This time I'm going to select scatter graph. Okay, scatter graph, variable. Let's choose weight. And another variable is I'm going to make a mistake and put position. Obviously, it says you must select a numeric variable. It's telling you numeric. So of course, height. Now weight is variable 1. It goes automatically falls on the x-axis. And variable 2 is height, so it falls on the y-axis. Now, another very technical term given to the x-axis variables is something called the explanatory variable. I hope I can pronounce it, blah, explanatory. So a variable which explains another. Now, this is the response variable. What it means in theory is this, that you are trying to predict height using the weight of rugby players. So once again, y-axis is height. So height is being predicted by using weight as the explanatory variable. Of course, you can do a lot of titles, etc. So what I would like to do is do regression line. Now, regression is a very formal word given to an LOBF. Do you remember that? LOBF. Line of best fit. Basically, it's so if I get a ruler, where will I draw a line which will cover on average the most amount of data? Will it be like that, or will it be like that, etc.? So I'm quickly running out of recording speed, 24 seconds. So maybe I'll do another video to carry on this. So regression line right there.